Hello everyone, welcome to my channel. I am Naveen Nayak and we are doing the Geology Optional Paper 1 course, and it is a comprehensive course on Geology Optional Paper 1 for UPSC, CSC and Indian Forest Service exams. And today we are doing the chapter 2, Geomorphology and Remote Sensing. In the last classes we completed the chapter 1, that is General Geology, and you can watch that videos. And before starting the class, Before starting, let me introduce myself. I am Naveen Nayak. I am let's see how we studied Geomorphology and Remote Sensing. You can see here, year-wise, 2020 6 questions, 2019 5 questions, 2018 7 questions. I can say that every year the 5 to 6 questions have been asking from this chapter, that is geomorphology and remote sensing, and so it is very important to learn this chapter to get maximum marks in the exams. Let's see geomorphology and remote sensing, and we completed the 2.1, the basic concepts of geomorphology, in the last class, and in today's class we will do weathering and soil formation, and we will start the slopes concept also. And without waiting, let's start the class. What is soil formation? How the soil formation is very important to know the soil definition. Do you know what is the soil? Soil is a layer of earth crust which serves as a natural medium for growth of plants, and it is a combination of minerals, organic matter, water and air. This is the definition of soil. It is a thin layer of the earth crust which serves as a natural medium for growth of plants. It is a combination of minerals, organic matter, water and air. And it is very important to know that, how the soil formation takes place. And this is the procedure. First, the soil takes place from weathering. Let's see what is weathering. What does weathering mean? Weathering is a process of deterioration, disintegration, decomposition of rock mass due to the effect of natural factors such as weather and climate. Remember, it is a continuous phenomena which weakens the strength of rock, thereby making it unsuitable to use as a construction material or in foundation process. You can see here how these rocks have been disintegrated. They are all are disintegrated. You can see weathering is a breaking down rocks, soil and minerals as well as wood and artificial material by contacting the atmosphere, the water and biological organisms of the earth. Weathering takes place in situ, in the same place with little or no movement. You can use either of the first one or two definition in the exam, whichever you feel easy. And let's see, weathering, the set of exogenic process, physical, chemical, biological, that alter the physical and chemical state of rocks at or near the Earth's surface. Intensity of most weathering decreases with depth because the variation in temperature and moisture decreases with depth. Therefore, biochemical weathering is generally confined to the uppermost few meters of soil and rock, occurs in situ. In situ means where the means place where it origins, not transported or alternation. Where they if the rock is at a location without transporting. Unlike erosion, which removes soil and weathered rocks, although the two sets of processes proceed simultaneously with positive feedback, the two forms of weathering act simultaneously and affect the nature and rate of one another. Disintegration produces an increase in rock surface area, while changes in strength with changes in composition. There are three types of weathering. First one is physical weathering, physical, chemical, and biological. Let's see what is the functions of weathering. Gives rock lower strain and greater permeability, rendering it more susceptible to mass wasting and erosion. Reduce strength and increases permeability of rock and therefore decreases resistance to fluid and gravitational stresses. Percures to erosion. Produce minor landforms. Produce landforms in soluble rocks and otherwise creates micro reliefs. Like example, weathering pits. Releases mineral in solution like iron oxide, silica, carbonates, which become concentrated to form hard coating on rocks and a hard resistant layer in soil that inhabits seepage and resist erosion. Fourth one, first step in soil erosion ultimately produce an unconsolidated mass. Unconsolidated means which is not sticky, which is separated. Minerals that resisted alternation, new minerals, organic debris. Means they will all separate. Types of weathering. There are three types. First one is physical weathering, second one is chemical weathering, and third one is biological weathering. Let's see what is physical weathering, then chemical weathering, and biological weathering. Physical weathering. Physical weathering is a disintegration of rock and soil aggregates by physical, mechanical process acting primarily or on pre-existing fracture, like joints, cracks between mineral grains, reduce the size of fragments according to rock and soil structure, producing grains, crystals, blocks, slabs, etc., with no change in composition. In the physical weathering, it will occur due to mechanical forces. Mechanical forces. Remember, you can see here how the disintegration takes place, how the rock is cut into two halves. You can see in this book also how these rocks are disintegrated from each other. Stress pressure release. First, disintegration of rock in parallel sheet as it expands in response to removal of confining stresses. And you can see this example. Most common mechanism of stress release is removal of overlying rock by erosion. Thus, this process is controlled by erosion but subsequently controls erosion. The dilution fractures conform to the surface topography and releases in space with depth. Thermal contraction due to cooling contracts expansion. Therefore, stress release is most pronounced near the surface where the rocks have already cooled and contracted. Also, most common in massive rocks, high thermal conductivity causes heat loss and thus reduces counter influence of cooling and contraction, fracture, or thinly bedded rock, which will expand with the outshooting massive rock stores stress until overburden pressure is very low. Stress release causes exfoliation, the separation of concentrated layer of rock. And this comes under the physical definition. Remember. Thermal expansion and contraction means the surface temperature of dark colored rock can vary from 0 to 50 degrees centigrade between day and night since a rock has low thermal conductivity. The differential stresses of expansion and contraction of the outer 1 to 5 centimeters of rock causes separation of concentric shallow layer called talus, or spheroidal weathering when it affects boulders. The ability of solar radiation to generate sufficient heating and cooling. Rocks disintegrate after fires, especially rock composed of minerals with a varying coefficient of volumetric expansion. Granite, the volume of quartz increases 3 times more than that of the flatspar. Dry granite, heated and cooled from 30 degrees to 140 degrees Celsius for 89,400 cycles over 3 years, produce no perceptible change even with microscopic examination, but 244 years is small amount of geological time. You can see here the thermal expansion and the contraction process, how we see here in the daytime. The heat which is heat will be absorbed, the sun heat will be absorbed by the rock. Rock surface heats up and expands. In the night, the rock surface cools and contracts, and after the joints form in the outer part of the rock. You can see here. After contraction and relaxation, the joints will form, and you can see here how the disintegration taking place. Original rock surface. After disintegration, the above layer will grow into pieces, and the same process continues. Growth of foreign crystal material in near to seas and oceans, mainly hydrated salts, which are water soluble at normal range of atmosphere temperature and humidity. They hydrate and dehydrate repeatedly, generating considerable stresses in fractures and between grain boundaries in permeable rock. The most granular disintegration. The minerals are transported in solution and precipitated as soil and underground evaporate. thus the most effective in desert landscapes, where water tables are near the surface. Origin of salts, seawater, chemical weathering of marine or evaporative sediments dissolved in snow and rain precipitate in lakes. Gypsum, relatively insoluble except in acid rain, thus enhanced weathering and acid rain. Hydration, wetting, swelling, and disintegration of soil aggregates. Layered and fine-grained fine-grained rocks. Also, pressure of air drawn into pores under dry conditions and then trapped as water advances into soil and rock. You can see in this thing how the crystal, how the growth of foreign crystals will lead to weathering. You can see here. This is the weathering, salt weathering of building stone on the island. You can see how the crystals will form on the rock. These are the rocks which is near to oceans or sea. They look like in white in color because the salt will all form on the rock. Expansion of clay mineral by volume. Co-Montmorillonite 45 to 185% and Montmorillonite 1400 to 1600%. Illite 15 to 120%. Selenonite 5 to 60%. In cross shattering and dehydration shattering, freezing of water in pores and fractures. The specific volume of water increases by 9% upon freezing, produces stress that is greater than the tensile strength of all the rock of all common rocks. Therefore, the stress generated by the crystallization of ice is most pervasive mechanism of weathering affects all rocks. However, the effectiveness of freezing water is influenced by lack of confinement. If more than 20% of pore space is empty, then the tensile stress may be less than the tensile strength. Thus, frost shattering is most effective in saturated rock. Ice under pressure deforms plastically and thus will extrude through daylighted fractures and pores. Decreased freezing point with increasing pressure and altitude. Necessary frequency and magnitude. Extent of frost shattering is a function of combination of frequency, duration, and intensity of a freeze-storm cycle. The water between the two rocks, the water collects in the rock crack. The water freezes and expands, forcing crack to widen, and this will lead to disintegration of rock. Ice flows, contracts, and water gets deeper into cracks. Here you can see the water is going deeper and deeper. A repeated expansion and contraction causes further cracks till rock split. You can see this is also physical. You can see here how the weathering taking place, how the rocks have been disintegrated into many pieces. Thin film of water do not freeze even at lower temperature. Given strong capillary adhesion to rock, powerful molecule forces in these thin films of semicrystalline water draw water along microfractures, opening and propagating them. Shallow freezing forces, films of capillary water along microfracture, disintegrating rock well below the depth of freezing. Hydrofracturing in the Allegheny Mountains. This is an example. You can remember this. Chemical weathering. Let's see what is chemical weathering. Chemical weathering is the decomposition of rock and soil and rock by biochemical process. Weathering pits form where water collects and accentuates rate of chemical weathering. Process. First one is oxidation. Process by which an element loses an electron to dissolved oxygen. Iron is the most commonly oxidized mineral element. You can see the reaction. Ferrous iron, ferric iron. Other readily oxidized mineral elements include magnesium, sulfur, aluminium, and chromium. Among the immediate chemical weathering process and gives altered earth material a crystalline yellowish brown to red color, and this due to chemical weathering the rock color of the rock will changes yellowish or red color. The water table is a broadly boundary between oxidizing and reducing environment. Next one is hydrolysis, decomposition of minerals in water as the hydrogen ion replaces cation in minerals. The pure water is a poor H plus donor. However, CO2 dissolves in water to produce a carbonic acid. Remember this reaction. Soil air is greatly enriched in CO2 by decay of humus. Up to 30% of soil air is CO2 as compared to 0.03% of atmosphere. And hydrolysis is the most important process in the weathering of silicate mineral. Next one, carbonation, dissolution of calcium carbonate in acidic soil and groundwater. Similar reaction has hydrolysis, but the dissolution is congruent, that is, the product are ionic. There is no residue. Bicarbonate represents the largest constituent of the dissolved load of most rivers. Cation exchange. Fourth one, cation exchange. Substitution of a mineral cation in solution for those held by mineral grains and crystals. Changes spacing in crystal lattice but not molecule structures. Most effective in clay texture. This is most effective in clay textured sediments as cations adhere to the surface of negatively charged clay minerals. Simulation. Mineral cations incorporated into hydrocarbon molecules. Complexing agents or simulators. Simulators agents are produced by alteration of humus in plant acids and excreted by leaching. Let's see what is biological weathering. Biological weathering is the deepening and subsequent breakdown of plants by plants, animals, and microbes of rocks. This occurs by plants, animals, and microbes of rocks. Growing roots of plants can put stress on pressure on rock. Even though the process is physical, the biological process exerts pressure. Biological process can also produce chemical weathering, such as when organic acids are produced by plants, roots, or microorganisms that will dissolve minerals. Microbial activity breaks down rock minerals by altering the chemical composition of rock, making it more weather sensitive. And remember this, it is very important in the biological weathering. Plants will disintegrate the rock and even reduce the dissolved mineral, and it will lead to the disintegration of the rock. Burrowing animals can make fragments of rock to the surface, exposing the rock to more intense chemical, physical, and biological process, thereby indirectly enhancing the weathering process. Examples: rats, rats in forest. You can see here how the biological weathering process. You will see the plant is growing in between the two rocks, between the rock, and the plant is the tree is disintegrating, that disintegrating the rock. You can see here how the plant is growing between the rock, and this is the physical weathering. Plants, microagents of weathering, maintain cracks between by other processes. Roots may pry rocks apart when tall trees sway in the strong wind. Root throw can break fragments away from bed. Roots is by weathering. And we all know soils are formed by weathering of rocks due to mechanical disintegration or chemical decomposition. When rock surface gets exposed to atmospheric applicable time, it disintegrates or decomposes into small particles, and thus soils are formed. Uh, Soil may be considered as a incidental material obtained from the geological cycle, which goes on continuously in nature. Soil is a complex mixture of minerals, organic matter, approximately 5%, and empty space, approximately 50%, filled with varying degree with air and water. The mineral content of soil is variable, but it is dominated by clay mineral and quartz, along with minor amounts of flatspar and small fragments of rock. The type of weathering that takes place within a region has have a significant influence on the soil composition and texture. See here how the soil formation taking place. The weathering of rock, and first stage is weathering of rock, and the second is the disintegration of rock, and after disintegration, the soil will form the mineral nutrients, ions in solution, oxides of iron on alumina, and silica, silt, sand, quartz. Based on the parent rock, the soil is formed. You can see in this how the rock is disintegrating. After disintegrating, it forms the soil, and is and how the soil is forming. The process of soil formation. You can see soil properties will show the parent material, climate, topography, organism, time. These all are the process in the soil formation. Soil formation through accumulation and decay of organic matter, and the mechanical and chemical weathering process described above. The factors that affect the nature of soil and the rate of its formation include climate, temperature, and precipitation amongst the following types of vegetation: the type of parent material, the slope of surface, and the amount of time available. Formation of soil, sand rock, and weathering, topography, organism, time. all lead to suitable conditions for formation of soil. Let's see what is the climate processing. Soil developed because of weathering of materials on Earth's surface, including the mechanical breakup of rocks and the chemical weathering of minerals. The downward proclamation of water facilitates soil development. Soil forms most readily under temperate to tropical conditions, and precipitation amounts are moderate. Chemical weathering reactions and biochemical reactions proceed faster under warm conditions, and plant growth is enhanced in warm climate. Parent material. The soil parent material can include all different bedrock types and any unconsolidated means separated. Separated sediments such as glacial deposits and stream deposits. Soils are described as residue soil if they develop on bedrock, and transported soil if they develop on transported material such as glacial sediments. However, the term transported soil is misleading because it implies that the soil itself has been transported. Transported soil is, for example, it is the alluvial soil. Alluvial soil. When referring to such soil, it is better to specific and say soil development on unconsolidated materials because that distinguishes it from soil development and bedrock. And parent material provides essential nutrients to residue soils. For example, a minor constituent of granite rocks is the calcium phosphate mineral apatite, which is a source of critical soil nutrient phosphorus. Basaltic parent material tend to generate very fertile soil because it also provides phosphorus along with a significant amount of iron, magnesium, and calcium. You can see here, this is the texture of soil. As the amount of clay increases, first 0, you can see here, soil, sand at 0. As the amount of clay increases, it will form clay soil. And silt, as the amount of clay decreases, it will lead to the formation of silt. And slope, let's see what is slope. Slope is a rise or fall of land surface. It is important for farmers or irrigators to identify the slopes on lands. And a slope is easily to recognize in a hilly area. You can see here, these all are slopes. These are slopes. Slopes are unsupported inclined surface of a soil mass. Slopes are embankment are commonly formed for highway or canal, canal banks, railway, etc. And slopes are classified into two types. Slopes classified into two types. Let's see what are the types. And natural slope and man-made slopes or artificial slope. Let's see what is natural slopes. Natural slopes are formed by natural attacks or causes, and whereas man-made slopes are which was made by man by cutting, side cutting, embankment, slopes, and slopes either natural or artificial are again divided into two types. What are they? Infinity slope, infinity, infinite slope, and finite slope. What is infinity slope? Infinity slopes has a constant slope with the infinite length. With the infinite length. And let's see what is the finite slopes. Finite slopes has a slope with a limited extent. And this is about the slopes. And see, let's see the natural slopes. Gentle slope. You can see here the gentle slope is the peak. A slope with the counter lines spread far apart from each other. This even spacing is maintained in both up and down slopes. You can see there is a spacing between these two slopes. Steep slope. This is a steep slope. Slope represented with the counter lines close to each other on a topographical map. Convex slope, a slope which becomes progressively steeper downhill. It can refer to an entire slope or part of one. You can see this is a convex slope. Concave slope. See here. This is concave slope. Slope which becomes progressively steeper uphill. It can refer to an entire slope or part of one. Tectonic slopes. These are formed through internal forces that result in the folding, wrapping, and faulting of rock masses or layers. Anticlines and synclines are formed when layers of rock are folded with a host, and graben rift valleys are formed when blocks of land rises or fall in relation to each other. You can see here. These are formed due to tectonic activities. Depositional slopes. You can see here. The river is depositing the soil and making the slopes. Deposits of weather materials build up to form inclined surface, mounds and hills. When an agent of erosion, which has lost its energy of motion, lays down its load in a particular slope elements. Let's see what are the slope elements. Crust. This is a crust, uppermost part. The cliff, which is a steep part. Cliff. Talus is sloping. Pediment at the base. Crest, a small convex shaped slope with a thin covering of soil, the edge of the hill. Convex, thin layer of soil, weathered materials removed. And cliff, a near vertical slope more than 80 degrees of vertical, greater than 80% to the origin. Layer hard resistant rock, loose materials falls to bottom of cliff. Talus, a slope with constant angle and is formed by of eroded materials from crust and free face, accumulates from crust and cliff face. And pediment, a lower angle concave slope, lower angle concave slope. Slope is not uniform and steeper close to the talus slope. And these all are about the slopes. And there is a one topic I have to tell, which is failures, type of failures of slopes. Types of failure of slopes. How the slope will fail. And there are rotational failure, second one transitional failure, third one is compound failure, wedge failure, fifth one is miscellaneous failure. And these are the types of failures of slopes. And these types of failures of slopes. And thank you for watching. Please like, subscribe and share.